Good day and welcome to our class. Today we shall be talking of convergence of sequence. A sequence this sequence, we know what sequence means. A sequence in this form is said to be convergent to a number L if the limit of that sequence exists at as n tends to infinity. That means if you can find the limit of this sequence as n tends to infinity, then we say that such sequence converges to L. So what we mean here is if this limit exists, and in this case when the limit exists we normally have this. So that means the limit of the sequence is equal to L, and that simply means that the sequence converges to L. So from this place we can have another definition of sequence. We have this definition again. A sequence is said to be convergent to L, or we say that it's said to converge to L if for every epsilon is greater than 0, because we are talking about limit here. So in that case we can define sequence in terms of epsilon, in terms of limit of epsilon. It's said to be convergent to L if for every epsilon is greater than 0 there exists a number n which is greater than 0. N of epsilon simply means that n usually depends on epsilon, such that for all absolute value of un minus L is less than epsilon, a small epsilon, n will always be greater than n. So this is another definition of convergence of sequence. Now, if we are asked to show that a sequence converges to a certain number L, it's either we go through this or we go through this definition. Now, let's take example. Before the example, sequence may not converge. It's not all the sequence that converge. If a sequence does not converge, we say that it does not converge, or we say that the sequence diverge. Is it a sequence that is not convergent is said to be divergent. So it's either a sequence converge or a sequence diverge. If a sequence converge, we have these two definitions, and if it does not, we see that the sequence diverge. So there's nothing concern us about this. Now let's take example. Example 1. We want to show that this sequence converges. Now if the question says that show that the sequence converges, we only need to show that the limit of this sequence exists as n tends to infinity. Now we start by writing the limit n tends to infinity of this sequence. The sequence is 4 plus 6n over 2 minus 3n. If you could remember how to find limit tends to infinity, remember that we divide both sides by n, so that this will become 4 over n plus 6 over 2 over n minus 3. So I've divided both sides by n. This will leave, it will remain 4 over this. Now as n tends to infinity, these two become 0. This one becomes 0, this one becomes 0. Here we're now going to have 0 plus 6 over 0 minus 3, and that will give me minus 2. That is 6 divided by minus 3. We have minus 2. So since we have minus 2, it means the limit exists. And if the limit exists, it simply means that this sequence converges. So in this case, we cannot say that, we cannot conclude and say that hence the sequence, that sequence 4 plus 6n over 2 minus 3n converges to its limit, this limit, to minus 2. So we have shown that the limit converges, and it converges to minus 2. The second example, show that this sequence converges to half. So here now, you observe that for this first one, it is show that the sequence converges. That is why we use this. But the limit is already taken and is given half. But we have to confirm it that this sequence really converges to half. So when we are giving this type of question, we need to use the second definition that I gave above. The second definition of the convergence of sequence, which is called epsilon definition. Now we start by saying from the definition, if for every epsilon is greater than 0, there exists capital letter N. There exists N. N depends on epsilon. So that means we want to find N such that small n is greater than capital letter N. Now, our un minus L is less than epsilon. That is what is given in the definition. What's our un? This is our un here. 3n plus 2 over 6n minus 5 minus L. This is our L here, which is half, is less than epsilon. Let's find the LCM. LCM will be 2 into 6n minus 5. And this will give me 2. We just need to cross multiply there. This is simple arithmetic. 1 times 6n minus 5 is less than epsilon. From this place, we should have, if you expand, that will be 6n plus 4 minus 6n plus 5 over, this will give me 2 into 6n minus 5 is less than epsilon. From this place now, if you simplify, we are going to have 6n minus 6n is gone. What we have left is 4 plus 5. So that should be 9 over 2 into 6n minus 5 is less than epsilon. So we now observe that for every n in that sequence, n runs from 1 to infinity. For every n, this expression is always positive. So in that case, I can remove it from the absolute value. I will have 9 over 2 into 6n minus 5 is less than epsilon. Now, let us interchange this. That is, we take this up, we bring this down. But we'll do it, the same thing will happen to here. This is epsilon over 1. I will write it like this: 2 into 6n minus 5 divided by 9. So, and from the knowledge of inequality, this sign will change to greater than 1 over epsilon. Then, if you take this to the other side, 6n minus 5 will be greater than 9 over 2 epsilon. Which, if we continue, we are going to have 6n is greater than 9 over 2 epsilon plus 5. Now, if you make n the same formula, n is greater than 1 over 6 into 9 over 2 epsilon plus 5. So, we have seen this type of relationship which says n is greater than capital N. So, in that case, we can say that we have found n. what's our n? This expression is our n. N is equal to 1 over 6, 9 over 2 epsilon plus 5. So we have found this n such that n is greater than capital N. So what we are saying there is that we have been able to find this type of relationship, assuming this sequence does not converge to half. What we are going to have there will not be greater, it will be less than sign. So since we are having greater than sign there, it means the sequence converges to that value, and we have found that n. So if you have found it, then you have shown that the sequence converges to half. Now let's consider a case whereby the sequence will not converge, and if you not converge, at the end of the day, the type of expression we are going to have will be n is less than certain thing. So that shows that the sequence does not converge. So let's move to the third example. Third example, determine whether this sequence converges to -2. So solution. So we need to start by saying for all epsilon is greater than 0, there exists delta greater than 0, such that absolute value of un minus L is less than epsilon. And our un, this is the sequence, is 4n plus 3, 4n minus 3 over 2n plus 3 minus L. Our L is minus, so it will make this place to be plus 2, is less than epsilon. And this gives me, if you find this, you simplify further, we have 4n minus 3 plus, if you find the LCM and simplify, we have 4n plus 6 over 2n plus 3 is less than epsilon. Our aim is to find a relationship of this format. If you cannot find it, if you can find it, then the sequence converges. If you simplify this further, we are going to have 8n plus 3 over 2n plus 3 is less than epsilon. And for all this, we know that this is always exists. It is always positive. So the absolute value is not needed again. It's always positive for n is greater than or equal to 1. In fact, if n is even 0, it will still be positive. Now we arrive at this. My aim now is to find the value of n. How do we find the value of n? Let's cross multiply. We have 8n plus 3 is less than 2n epsilon plus 3 epsilon. From that place, if you collect the like terms, we have 8n minus 2n epsilon is less than 3 epsilon minus 3. N is common. I'm only trying to make n desired formula. N is common. We have n minus 2 epsilon is less than 3 epsilon minus 3. So if we make n desired formula, n will be less than 3 minus this over 8 minus this. So we'll now see that we did not see a relationship whereby n is greater than this. We are seeing a relationship of less than. And since we are seeing a relationship of less than, that means we cannot find n such that n is greater than. We cannot find capital letter n such that n is greater than n. That capital letter n will always depend on epsilon. So in that case, we can conclude that therefore the sequence un is not, we can quickly see that the sequence un diverges, does not converge to -2. So it diverges.